to get work, what do we do?
Hannah.
You're in basic calc, right?
Oh, okay, like, yeah.
How do you make this dw instead of dw?
Take the integral.
Yeah. But, so we're going to take the integral with respect to times, but this isn't in terms of times. So what we're going to do is, we're going to say the power is equal to force times velocity.
Yeah.
Force times velocity. Okay, what is velocity in terms of time? How do you get velocity?
It's distance over time.
Oh, yeah, we were 8.
It's distance divided by time.
You have to use acceleration.
Now this year it's only the top 7.
It's the integral of acceleration.
So we're not going
dA.
8 is great.
AT.
What? Okay.
Because if you're accelerating 5 meters per second squared, so how fast have you moved? What's your velocity after 3 seconds?
Next year.
If you're what?
So if your acceleration is 5 meters per second squared, what's your acceleration after 3 seconds if you started from rest?
15. Yeah.
Yeah. So velocity is the same thing as AT.
Okay.
So then we have
acceleration
equals F times A T times T dt. All right. So then, to get the amount of work done in the first second, you take the integral from 0 to 1.
Okay, go.
Okay. And then when we take the integral of this, force is a constant, right?
So it's just
Force comes out of front. Acceleration is a constant.
Oh, no, we don't.
Oh. Okay.
The only thing that's not a constant is t. So what's the integral of t?
1/2 t squared.
Yeah.
Oh, yeah, I remember that, yeah.
Okay, right?
Yeah. Yeah.
So then we're going to plug in 1. So what's the force?
5.
Oh yeah, 5. They just gave it 2.
Okay, what's your acceleration? Let's figure that out.
0. Well, it's at rest.
No, force equals ma, right?
Oh, okay. Well, so it's 15 or 5 divided by 15, which is a third.
Yeah, so 1/3. Okay, times 1/2 times t squared. So we're going to
Is 1.
1.
Yeah.
Minus, and we're going to do the same thing, evaluate it at 0.
So 5/3.
Yeah, they're moving around in the dark. They're really blurry. So
So that's just gonna be 0. So it's 5/6.
What?
5/6. Sixths.
Oh, you pronounce every letter.
Yeah.
Because my mom had the same problem. She was taking pictures.
And so that is.
What's work?
you guys
What's
don't have
the
real bright light.
it's joules,
Oh
right?
yeah, joules.
If I use flash,
From 0 to 1 seconds. I think that's the right answer.
Is that what
Yeah.
we're supposed to find?
The amount of work from 0 to 1, right?
We got some good pictures.
Compute the work done by the force in the first second, the second, and the third second. So then, to get the second second, we're going to do the same thing, except this is now 1.
And that's 2. Oh, so we're literally taking. Oh, okay. All right.
And
Let
then
me
for
write
third,
this.
this is in the third second, because this is our graph, right?
Yeah. Yeah. No, it makes sense. It makes
This
sense.
is 1 second, 2 second, 3 second, and you want to find the area of this, then the area of this, and then the area of that.
Okay. So what equations do I need to remember in order to do this?
These two.
Yeah.
I have that written down. Power is F dot D F. Dot, is it dot V dot? Wow.
So if
F
there's an
dot
angle-
V or okay.
So this is equals.
Well, and they like changed a few things
Yeah.
to adapt to
Yeah.
That's the same thing.
Okay. But then,
That's what the dot.
so how is this power different than the instantaneous power? This is like total power.
All right. So check this out. So, what's the equation for work?
Work to F dot D.
Okay, so we do d dt of what do you say it was?
F dot D.
F. We're just gonna say there's no
Yeah.
angle.
Okay. F times.
Force
Yeah.
times
Force
the distance. Okay. How do you get distance? It's your 1D equation.
Like wait, in terms of what? Or
So you know I have your acceleration, your velocity, and your s. What's your equation for s? How do you get s? How do you get displacement? What's the equation for displacement? You should know this.
velocity over velocity over time. This is. Oh. Wait. What do you?
Velocity is the integral of the
Yeah,
acceleration.
it's the integral of velocity.
Okay, so what is that? You should know what this is.
VT. Or
All right, so your 1D equation for displacement is 1/2 a t squared.
Okay.
Okay? Plus, put plus v o naught t plus s o naught. Well, we have no original, right? There's no original velocity, so that's what our distance is. So we're going to say this is force times 1/2 t squared. That's force times distance, right? So this is work. Okay, so then what happens when you take the derivative of this? Force comes in the front because it's constant, right?
Mm-hmm.
1/2 is a constant. Acceleration is a constant. Okay, now what's the derivative of t? T squared.
dt. Oh, maybe 2t dt.
Okay, 2t. Yeah. Well,
You don't need that. Yeah.
okay, the 2 cancels out with the 1/2.
Yeah.
So we get F times A times T. What's AT?
Velocity.
So equals force times velocity. That's where this comes from. Taking the derivative of work times power. Are you following me at all?
Yes. Wait. So you're
That's
saying
where that comes from. You don't need to know how I got it, but these two are equivalent. They're the same thing.
Ah.
This is just like
So wait.
saying...
So does this mean that power is the derivative of work?
Oh, I want to do that. We try to do it with 4 girls, but then like the other.
Yeah.
Keenan and Caroline, I hate
respect
to
to
ask
time.
that you did all.
Okay, because work.
You guys also clean.
Power is the instantaneous of work.
That makes sense now. That makes
Instantaneous
sense.
rate of work.
Okay.
Because you know how velocity
Is like-
instantaneous?
Yeah.
Okay, that's the same thing. That's what power is. Instantaneous rate of work. That's how you get the equation.
This is number.
Okay?
Okay.
But you don't actually need to know that. All you need to know is F dot V. Or so you could have done this problem.
Yeah. Is there another way? Well, you're gonna have to take the integral somewhere.
No. Okay, so if power equals F dot V, right?
Mm-hmm.
So at you know the acceleration, right? What did you say it was 1/3?
Yes.
Okay, so yeah, you could say if you want to get the work done in 1 second, I think this is probably the easiest way to do this problem actually.
Okay.
Okay, but
So
then
you just had to be able to get here to take the integral.
Kelsey was only going to go if I go, and now
but then for the last part, you want the instantaneous power due to the force at the end of the 3rd second.
You want the instantaneous force
No, instantaneous
or
power.
instantaneous power at the end of the 3rd second. Okay.
Instantaneous power to the force at the end of the 3rd second. So do you know how you do that? We just use this. So what's the velocity?
Not this one.
No, this.
Okay.
This is instant. This is also instant.
Oh, okay. Then how are these two different? Oh, this is
not.
This is. Oh, okay. You're literally just saying that power is a derivative of work here.
So yeah, so at the end of 3 seconds, how fast is it going? If it starts from rest and it has acceleration of 1/3.
After 3 seconds.
Yeah.
Of 1.
Okay, so your velocity is 1.
Yeah.
And what's your force?
Your force is 5.
So your instantaneous instantaneous power
Is
at
5.
power is watts.
Power is watts.
5 watts is the instantaneous power at the end of the 3rd second.
Okay. Okay. Force is newtons. Work is joules. Power is watts.
Yeah.
Got it. There's not.
The
There's,
only difference between instantaneous, but for this part, they didn't ask for power. They were asking for your work. That's why we had to rearrange it like this. Follow me?
Yeah. Okay. Yeah. So you had to use this in order to.
So we used this and we rearranged it so we could solve for W.
Got it. Okay. No, it makes sense. I'm just gonna need to remember to actually do this. Okay.
43.
Do you want to do this problem or do you just want to go